Good day and welcome to another edition of our series Introduction to Statistical Analysis and Machine Learning with Python. Today we'll continue from where we stopped in the last tutorial, continue with conditional selection. What we've been treating for the past 1 week is data analysis with Python Pandas. So let's go on with it. So basically we can select columns and rows in data frame conditional. So this is our data frame, for example. So we want to check for where we have our variables greater than 0 in the data frame. So basically this one will give us a true false response. So wherever it is greater than 0, give us a true, and whenever it is equal to 0 or less than 0, it will give us false. So that's why it's giving us this. So we can now convert those true to the actual number and convert those false with not a number by just imputing this condition into like the conditional selection of our data frame. So, and that's basically what we are doing here, conditional selection. You can see not a number for all the falses and the numbers for all the trues. So here is another one here. So basically we are still like writing exactly the same thing, just that here here we are using the colon W, which is this colon. We are using the colon W. That's why you notice the row with the not a number automatically disappears in the W. That's the row C. You can see it's no longer here, so it just appears for all of them. Then we can use it conditionally to now select for a particular column, which is what we did here. You know, here we did for the whole number, the total, the whole data frame. Here we are doing for a particular column. Here we are doing for 2 columns. So that's what we did there. Then we can use pipe and ampersand. So the pipe symbol is just an OR operator, meaning wherever you have a true, that is, if either of the sides is true, if either of the sides is true, give us true. But if both sides are false, give us false. So if we have one of them to be false and one of them to be true, it give us true. If we have one of them to be true, it will give us true. If we have one of them to be false, it will give us true. If we have both of them to be true, it will give us true. But if we have both of them to be false, it will give us false. So the only condition where this will be false is when both are false. But by the time we are using ampersand, it is only true when both are true. So whenever we have a single false, it will be false. So that's basically that. So you can see here is just the C colon that disappears. But if I use the ampersand now and I do that, you can see it's only one row that is displayed to us, meaning it's only one row that both are true. So that's that about that. So more on index details. So let's discuss more features on index, including resetting index, setting it to something else. We'll also talk about index hierarchy. So let's point out our data frame again. Then reset index. We will reset our index here. This is the function to reset index. It will make your initial index to be a colon on its own. Then to give us the normal index. Python data frame will give us 0, 1, 2, 3, 4. So that's that on that. So we are now having our new index. Here we have space in between our variables so that we can split them into a list. In case you don't understand what this split function is doing, check my series on 0 to 0 in Python programming. You understand what that split is doing. So here is another one. So we are now setting the list we form here to be data frame states in our data frame. So if we print out our data frame now, you can see states as California, New York, West New York, Oregon, and the likes like that. So multi-index and index hierarchy. So here are our indexes: outside, inside, list. So here what we did is we just zipped this together. So it will be more like we are having a tuple in a list. So this and this will be zipped together, and it will be the first variable in the list. This and this will be zipped together, second, like that, like that, like that. So that's what this is now giving us now. So we are now making it into from tuple into a multi-index stuff for pandas. So you can see what I'm saying. So this is what our first function did, this one here. Then we use PD multi-index to give it this extra bracket, which makes it a multi-index data type. So going on from there, we can then create a new data frame with 6 by 2 matrix, that's random number, random dot rand n. So 6 by 2 matrix. Then index will be our hierarchical index that we formed. Then our column name will be A and B. So if we run that, you can see we formed a new data frame with multiple index. If you notice, G appears just once in 3 of these rows, and that's because G1 is common to the 3 rows and G2 is common to the 3 rows here too. Same thing, and then we now have the 1 2 3 1 2 3. So that's that on that. So now let's show how to index this. For index hierarchy, we use location, that's the LOC. If this was on the column axis, we will use the normal bracket notation, which is this. So we use the location for the one with multiple index, but the column axis we use our normal square bracket notation. Calling one level index return the sub data frame. So for example, we call the G1 now, you can see it brings us the 1 2 3 of the G1. So same thing with here. So we now call location 1. So location G1, location 1 is more like calling having a list of lists. So you're now calling a location, a position in the list inside a list. So that's what we are doing here, and that's how it's giving us this. So it's more like it's just giving us this place alone. So here is another one, index names. Then we don't have any name for our indexes. If you notice here, there is no name attached to them. So we are giving it a new name now, group and number. So we run that and we'll print out our index. You can see group number, and that's that on that. So now we are calling our G1, our G2. This is just telling us that this will be deprecated. This is deprecated already. So in future versions of our pandas, it won't be working again. So what we did here might not work in future versions of our pandas, but it's still working now, so we can still use them for the meantime. So here is another one. So we are using the level number and we are picking 1. So that's more like what we did here, where we picked just G1. So that's that on that. So now working with missing data. So missing data, okay, yes, we're creating a new data frame, but we've added NPNAN, NPNAN, NPNAN. NAN is just not a number, so it's a NumPy data type. So we print out our data frame, you can see NAN, NAN, NAN. So if we say drop NAN, it will drop the rows with NAN. But if we put axis equals 1, you know by default, it will always pick our axis to be 0. So if we pick our axis equals 1, it gives us this. Then if we set our threshold to be 2, meaning whenever we have 2 or more missing variables, drop that particular row, but else don't drop it. So that's basically what we did here. And if you notice, we have 2 and above here, so it dropped this, but we have just 1 here, so it did not drop it. So that's that. Then we can fill our NA with a value we like, but mind you, we didn't put in place equals to here, so it's not a permanent thing. But we can say for our A now, fill the value with the mean of A. That's what we just did here. Fill NA, then value equals this. You can say our value equals fill NA here. So basically, this is what we use to find the mean of a number in pandas. So once we find the mean, which is said to be our value, then we fill all the NAs in our A. So if we run this, now you can see 1.5 here, and that's basically 1 plus 2 equals 3 divided by 2, which is 1.5, and that's what this is giving us. So group by. So basically, group by is to probably group a, let's say you are working with an organization and you want to get the sales of maybe different, maybe you are using a centralized database and you want to get the sales of different outlets. So you can use group by for that. So here, don't worry, next week we will treat more on pivot table. So you understand how to do pivot table in pandas. So you will be able to understand what I mean by this group by more further. So we have 2 Google, 2 Microsoft, and 2 Facebook. So we can group by company. So once we group by company, we can call anything. So we are now assigning our group by company. So we can now call the mean of each outlet, like each company, like Google, Facebook, Google, Microsoft. We can call it as we are still calling mean here. We can call the standard deviation. We can call the minimum. We can call the maximum. We can call the count, like number of customers, number of response they had for that particular day. You can call describe. Describe is one of the major data analysis tool. When I'm doing exploratory data analysis that I use, it is the first thing I use to check what is going on with my data. And as you can see, it gives you the count of your data, then the mean standard deviation. Once you notice your count is not equal all the way, it means something is wrong somewhere, meaning there's a missing value somewhere. That's for your normal data frame, not for our group by here. Of course, you might have different numbers for your group by. So here is describe transpose for you to be able to see it better. So we have the company names here. You can see this is now looking like a new data frame on its own with our double hierarchy indexing. So that's that. Then we are now speaking for Google alone here. So merge, join, and concatenation will be treated from our next tutorial. Thank you for joining this tutorial. Don't forget to subscribe and click the notification button, and don't forget to like this video. Remain blessed. Thank you.